there are chances that the model which has been deployed, okay, the data which it has been trained on is already biased, and hence we cannot expect the model to be very performing unbiasedly, right? So how do you deal with that when all the data already has been biased? If you can explain a little more.
That depends again on a case-to-case basis on what kind of problem you're trying to solve. Can you identify the biasness, right? That's the first question. If you can identify that, okay, this model is somehow biased against gender, particular gender, then you can then try to do some, okay, at least there are a lot of approaches, at least the ones that I have tried are largely very similar to what we do if we have one class very high numbers and another class very low numbers, right? So unbalanced data sets. So what do you do when you have unbalanced data sets? You either oversample or you undersample or you use SMOT or methods like that, which you can then use here. You can figure out, okay, within this class there is smaller number of people, let's say insurance. Within one gender there is smaller number of people who were accepted and a larger number of people who were not. So let's make more records of the ones that are. So something like upsampling and then work with it, or do downsampling on the other hand and work with it, or something of that sort.
Welcome to Data Science Dialogues, the podcast where we dive deep into the world of data science and analytics, going beyond the lines of code to explore the crucial business aspects that drive innovation and decision making. I'm your host, ST, and each episode will be joined by industry experts, thought leaders, and pioneers in the field of data science and analytics.
Today we had Shri Harsha, a remarkable data scientist at Deloitte, armed with a master's in business analytics from Imperial College London and an esteemed alumnus of Indian Institute of Management Bangalore. Harsha's expertise spans machine learning, AI, and NLP. His 6-year tenure in data science, coupled with 4 years in NLP and computer vision, has left a mark with deployed projects at Walmart, Rolls-Royce, Dr. Reddy's, and Olam. Proficiency in Python, R, and SQL. Harsha crafts impactful solutions across diverse sectors like pharma, supply chain, and retail, harnessing data for actionable insights. Harsha, welcome to the show. Thanks for making the time.
Hi, Samideep. Thanks a lot.
Yeah. So, Harsha, we will dive right into it. I have been a student of economics, and after dealing with a lot of statistics and mathematics, I figured out, that I am pretty good at making sense out of numbers, and hence, chose data science as a domain. It's fascinating to see your journey, from studying mechanical engineering to delving into the world of business analytics and intelligence. What inspired you to shift your career path like this, and how did you discover your passion for data science?
Yeah, so my journey would be not that interesting. So after my bachelor's, I got a job at Mu Sigma, and initially I was working with supply chain, which is also related to mechanical, but not like core mechanical, I would say. And from there, I went into supply chain analytics. I worked for one of the Fortune 10 companies with analytics with them, with data science with them. And since then, I transitioned into data
Stop it,
science.
Harsha. You know, you have not only completed a master's in business analytics from Imperial College from London, but also pursued, business analytics at IIM Bangalore. So one question that
Yeah.
strikes my mind is how, what are the educational differences did you observe in both the colleges?
Oh, both are prestigious colleges, very prestigious colleges, globally, right? The difference I found, let's say, and maybe this is because of the course I'm working on, the difference that I found at IIM Bangalore is generally the age of the students was much higher. The age of my peers was much higher. Most of them had a lot more experience than the ones that I was doing at Imperial. And at Imperial it was more vibrant, but the education wise there's not a lot of difference. So I keep telling this to my peers who keep saying that somehow education in the West is better than education in India. That's not necessarily the case. If you go to a good enough institution like IIM Bangalore, and also one of the top 10 universities like Imperial College London, I don't see that much of a difference, at least in terms of rigor, in terms of um, quality of peers. I mean, in almost any metric. The only difference I see at Imperial is the internationalism, where I do see a lot of people from a lot of backgrounds, from a lot of countries as my peers. And of course, they say that peers is at least 50% of your journey at any college or any education. So that does matter a lot. But if you take a good course, I mean, if you have very good peers, it doesn't really affect that much. Also, I think some of this is clouded by COVID-19 when I studied at Imperial. So, yeah, when I studied at IIM Bangalore, most of it was offline, so I was able to attend the classes, meet my peers, etc. When I was doing my master's in London, half of it, at least more than half of it, was from home or from online, where there was not a lot of interaction. And most of the interaction was in the second half of the course. So yeah, so maybe COVID-19 also affected it a little bit on how we created relationships and what kind of activities did we do as peers.
Got it. So I understand that you don't get 100% when you are doing it from home as
Yeah,
compared to when you were in IIM Bangalore. It was completely offline, and you were with their peers while you were working, right? Yeah,
yeah.
great. So, Harsha, I have been, solving multiple data science case studies now and then, and I realized that such cases, or projects require a theory or framework to follow. Okay, though all cases are different and perhaps be approached differently, what works for you? What framework works for you in approaching such cases?
So there are a couple of things that are directionally towards what I think, right? So first thing is something called as Prism DM, PRISM DM. That's largely a data engineering or a data analytics kind of methodology. And there are other methodologies like PDNA, which is problem DNA, and similar stuff. So I use a combination of them based on my experience of what works. So yeah, let's say, see, generally these days, whenever a business tries to come to us, the first thing they give us is data, and then they ask us, and then they talk to us about the problem. I generally don't like looking at the data, at least at the initial phases. So if you look generally, and I'm talking, so I'm a consultant, right? I'm a data science consultant. I have worked with multiple clients, and I've seen my peers work with multiple clients. So my experience, and this is also generally accepted. I mean, if you type it in the Google, is that almost 85% of all data science projects are not productionalized. That is, they are not finally used by any business. Probably there's no other industry in the world where 85% of the whatever work you do is not actually deployed, not actually used, and you still get paid, right? So data science as of now is a fad, so it works, but once it becomes, I mean, even now it's serious, but once it becomes a little more serious and people really think about, are we getting the results that we want, are we paying for the real results, then yeah, 85% of projects not getting deployed is a shocking figure. So I have similar situations in my experience. Also, some of the initial projects that I worked with, POCs that I worked with, were largely unsuccessful. And what helped me was experience and help from, let's say, seniors, and and this methodology that I, over a period of time, framed it. So what happened? Okay, so at least this is the framework that I follow. I don't look at the data initially. I first look at what the problem statement is. I try to understand what the business is. I try to understand uh, what is there is something called as SGQs, which is what is a current state, what is a future state, what is a statement, what is the question that they're trying to answer, etc., etc. Once those things are clear to me, like what do they want, how do they want it deployed, what is the business objective out of this, how do I measure success for this use case, etc., etc., then the next step I would do again is feature engineering. So not feature engineering per se, but something like a Mickey kind of analysis, mutually exclusive, collectively exhaustive kind of analysis, where I determine what are the features that are required to solve this problem. So there can be multiple features that are not given by the client or by the person, by the business to us when we are trying to solve the problem. It could be that they have overlooked these features. It could be that these features could be maybe explained in a different way. Again, from experience, the difference between an okay model and a best model is at max, from my experience, again 2 to 3, maximum 5% accuracy, right? So if I build, let's say, a gradient boosting model versus a decision trees model, the difference in accuracy is generally 5%. So I'm just taking an example from the same family, but you could take it across different families and get the same similar accuracies. What would happen if you have a very good feature, on the other hand, is that your accuracy can improve 10%, 15%, 20%, and so on. So if you don't have a good feature, even if you have the one of the best models that you're trying to build, it will not be successful. I mean, the project will still be incomplete. So before looking at the data, I do have a Meki kind of analysis, which is mutually exclusive, collectively exhaustive. I sit with the business, I sit with my team members and clients and whatever subject matter experts, and then I kind of write down what are the features, sit down and discuss how to group these features in a mutually exclusive, collectively exhaustive manner. And once that is done, then I also try to think at least what kind of hypothesis tests can I do for each of these things. So how would the hypothesis tests look like for each of these features? And then I go back to the business and then I ask them, okay, can you give me the data? Once I have the data, either I have these features or I don't have these features, right? If I have the features, then that's nice. If I don't have the features, then see, some features you can't get them directly, but you can say that some other parameter or a feature or a computation of some features or something is a representation of that, is directly correlated to that feature or something of that sort. For example, I was working on a demand on a forecasting problem where I'm trying to forecast what is the lead time uh, of some project, and I don't have specifically whether the supplier has the item or not, but I do have whether uh, in the recent past whether that supplier has delivered that item, in the recent past whether some, for that same item or similar items, whether other suppliers have delivered it or not. So these are mock features for determining shortage. If I have something like last 5 orders for this item across different suppliers, that's a mock feature for shortage. I don't have shortage for that whatever variable or whatever product, but I can create a mock feature for it. These kinds of thinking, these kinds of thoughts can happen once you have a mutually exclusively, collectively exhaustive list of features. Once that is done, once I have the features, then we can do some basic hypothesis testing, and then more complex based on whatever the client wants. And then comes EDA, which is another major chunk, I would say. Again, generally I have a strategy of my own. So see, at the end of the day, features could be continuous or categorical or time series, just one of the three types. And your problems, generally the things that I solve are either classification or regression,
Right.
right? Or time series related problems. So it's not complex. You can just create a table. What is it for dependent variable continuous, independent variable categorical, continuous, continuous, categorical, 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 continuous. Same thing extended to time series. You have a table now, right? And for this table, for let's say continuous, continuous, what kind of visualizations are you interested in? So it's not like what kind of visualizations will work, but okay, based on the hypothesis that you would have, if it's a continuous variable, what kind of visualizations would be applicable for that? For example, for continuous variables, you could have a scatter plot because you're interested in correlation. For a categorical variable, you can have a mosaic plot, which is essentially going to tell you whether there's any difference between A versus B in terms of their counts, because if you look at the hypothesis test, it will be something very similar, right? Uh, so these kinds of visualizations, you can give a little bit of thought to it and then figure out and then have a standardized at least for yourself, a standardized version of what to do A versus B and some basic EDA, which is, I would say, more explorative in nature and not more directional in nature, right? So this is an EDA that you would do for any data set that you get for all the variables that you have. And then you have directional EDA, which is again mostly led by, let's say, the subject matter expert and the clients and etc., where they are like, we think that so and so is happening. Can we look into that? And these kinds of things. So that is a little more directional EDA, which then happens. And once all of these happens, we again consolidate back, recreate the features, check for correlations. If that's a model that we need correlations, check for null values, figure out if there's some kind of outlier treatment needed to be done, and then essentially build a model, right? But even before all of this, there are other questions to think of. How do they want it deployed? Do they want explainability or not? They, as in the clients or the business, whoever is going to finally use the product. Because you can build a very good model, but if it's not explainable, so for example, I was working with retail client where where the customers that would be using these products are store managers within different stores. Now you can build a very complex product and give it to them, but they will at the end of the day say, okay, I don't really understand why this is so. So we were trying to build what products to place at which part of the store. So if I say, okay, milk should be placed beside bread, for example, and they would come back to me and say, see, we have far more experience. You just came in like 2 months into the org, 3 months into the org, whatever, and you're telling us changes that you want us to change things that have been working for a long time. We will not, they'll not be convinced to change things. And they will usually, this is the reason, I mean, these are some of the reasons why things fail. So you need, in those cases, you need a lot of explainability of the models. You need to explain, you need the models to be explainable so that people who are working on it will get convinced. So you can't use, let's say, neural networks because they're not that explainable. You can't use more complex things. You can only use simpler things which can then be digestible in nature, right? So yeah, explainability is a factor. Second thing is deployment strategy. For example, I was working for an airline client within an aircraft engine where the deployment strategies are different because an aircraft engine has limited space. I can't use extensive or more complicated libraries, and I can't use way more complicated models. I have to be very simple in nature. And also there's an explainability component with aircraft engines because again, everything traces back to safety, etc. Right. So these are a lot of things that you should think before, and you should decide before you actually build a model. Building the model is not that complex, at least these days, right? On top of that, you have to also think about, let's say, GDPR and privacy guidelines these days, and you should also think about whether you can include um, certain parameters into the model, let's say gender or any parameter that's even correlated with gender or uh, something like age. And it again depends. So if you're in an insurance industry and if you actually are interested in that, I mean, whether a person smokes or not, that then that becomes a feature. But in general, if that's not the case, you need to figure out which variables will not cause any bias within where it's being applied, and you also need to see if there is any existing bias in the data. So for example, I was working for one of the insurance client where they claimed that they don't have any bias in their models because they don't have either gender or race or any of these features. But if you even look at the model and if you look at the data that was given to the model, that was still biased. So the biasness is inherent because the past data is biased. So even though gender or name was not there or for some other parameters are not there, the data itself is biased. So what should you do in those cases if the past history itself is biased? You have another challenge. Okay, you may think, okay, great, I'll do a classification model or something. But once you look at the data, you may figure out that I don't have a lot of failure cases. How do you deal with those situations? So or you don't have a lot of data, which is also a primary issue that I face with. So clients do say, okay, we have tons and tons of data, but at least the clients that I work with, which are uh, just going into data science, which are just implementing some of their first models, which are just building their analytics center of excellences. They think they have a huge amount of data, but really how much of that is usable, how much of that is trustable, right? What is the veracity, etc. So these are different things that you should think about before you can actually deploy a model and before you can give some confidence and say that okay, the model is going to be deployed, etc. So yeah, if some of, let's say, veracity is not there for the data, then I think the first thing that you should do is proper data engineering before you come to data science. So you should think of what are the challenges and how to tackle them before jumping into quote unquote model building, as I say.
Got it, Harsha. So a great framework, in fact, that you start with research, okay, rather than looking at the data first,
Yeah.
because looking at the
Yeah.
data first initially might cause some bias in yourself before you build the
Yes.
model. Then you use MECI to feature engineer, and then also comes the consumption of the model. Okay, right? Like you cannot give something which is not explainable to them. So that is where the importance of explainable AI comes in. And then Harsha, you touched a very important point that there are chances that the model which has been deployed, okay, the data which it has been trained on is already biased, and hence we cannot expect the model to be very performing unbiasedly, right? So how do you deal with that when all the data already has been biased? If you can explain a little more.
That depends again on a case-to-case basis on what kind of problem you're trying to solve. So can you identify the biasness, right? That's the first question. If you can identify that, okay, this model is somehow biased against gender, particular gender, then you can then try to do some, okay, at least there are a lot of approaches, at least the ones that I have tried are largely very similar to what we do if we have by uh, I mean, one class very high numbers and another class very low numbers, right? So unbalanced data sets. So what do you do when you have unbalanced data sets? You either oversample or you undersample or you use smart or methods like that, which you can then use here. You can figure out, okay, within this class there is smaller number of people, let's say insurance. Within one gender, there is smaller number of people who were accepted and a larger number of people who were not. So let's make more records of the ones that are. So something like upsampling and then work with it, or do downsampling on the other hand and work with it, or something of that sort. So, and again, the segmentation shouldn't go too further because naturally in any population versus sample scenario, you will not have uh, I mean, the means will not exactly be the same. So you should also figure out where to stop that, right? If let's say a mean was slightly higher with respect to one class versus another class, you have to then figure out whether that's statistically significant, whether you have enough data to actually say something, and then think about these things. But generally, if there's a huge bias, you can do something like upsampling, downsampling methods to look into how to solve these issues. At least that's one of the approach I've used. I think there are other approaches which at least I've not explored.
Got it, Harsha. So, with your background in both technical and as well as business education, how do you approach the task of effectively, communicating complex data science concepts and insights to non-technical stakeholders?
Yeah, couple of ways. I would say most effective ways to build a brief basic app. So as a data scientist, if you either know Flask or Streamlit or something, it's actually way useful, right? If you know how to integrate a model and show it not just in numbers or in Excel or a Jupyter notebook, but some format which is more consumable, where you can actually give input to numbers and then it gives you an output and maybe a little bit of explainability how it works, etc. That's actually mostly what the business wants, right? Most of the businesses, at least these days, are not thinking of understanding each and every small detail of the data science problem that I'm solving. So they don't really need to know what is sampling, what is population, why did I take a training data set, test data set, if I give test accuracy versus training accuracy. Some of these, yeah, some people, I mean, a lot of them are interested what are the differences and how we are building things. But if it's like a purely business oriented let's say person, build a small dashboard, put your model in an explainable fashion within that dashboard, make it interactive so that you can give some numbers into it and get some output out of it and try to explain that output. Mostly that is sufficient, and what they will do is they'll then take the small dashboard and then use it in other places where we did this, let's say for the retail client where we had explainability issues with store managers, where we created a small app, and then that actually blew up, where the store managers were then able to understand. You just need to make them understand 5 6 use cases, and after that they'll trust you. And once there's trust, then inherently there's lesser number of questions coming towards you, right? So yeah, that's at least like the first step, I would say, or at least that's my strategy as a consultant. But again, if you're working on some problem where the business understands a little bit of data science and you need to explain, you need to go, right? I mean, yeah, there's a explain as if I'm five, but there's also explain as if I'm, let's say, high school, and then there's an explain as if I'm a graduate. So you were talking about the differences between the Indian, let's say, quote unquote, Indian way of working, and at least what I saw is the UK way of working, the London way of working. People in India, at least from my observation, are not that confident for whatever reason. So if the client says do this in ABC way, most people try to do it. Most Indians, at least, with whatever I have experience, I'm talking just from my circle, they try to do it in that XYZ way. In fact, some people go overboard and they try to figure out how does the client want to actually do this, and then do it in that way. What happens, at least outside, is people have a lot more confidence on their skills, and they in fact tell the client, if the client comes back and tells you do it in this way, they say, okay, that may not be the right way to do things, this is the right way to do things, and then they do it, and then they show them that this is the right way to do things. So that difference exists. I would say one of that main difference is communication issues, because we are afraid, okay, if we do it in a different way, how are we even going to communicate this, the result or the process, back to the clients, and then convince them that, okay, this is the right way to do things. Versus people are more confident, let's say, in the West, where they are like, we will do it this way and this is the right way. I mean, they'll obviously consider what the client is saying, but at the end of the day, they will have a discussion and then do it the way it should be done versus the way client thinks it should be done, right? So another reason why a lot of these problems don't go into production is, at least from Indian standpoint, is that we think, what is a client thinking? How does he want to solve it? Rather than this is how we should solve it. Sometimes when you propose your method, client comes back saying, okay, this is too simple, this is too complex, whatever. You take their inputs and refine it, or you stand your ground and say, okay, let's build this version first, and then let's look at improving it, right? So I would say effective communication is still an issue in the Indian market.
Communicating it correctly to the client, you can have two perspectives, that you stand your ground, that you are what the solution that you have proposed is something that should be implemented. On the other hand, there are clients you deal with where you have to accept at times that, yeah, this I have to think from the client's perspective and then refine it again. Great. So in your
So
experience.
also, because this is a, I mean, yeah, data science is a serious industry, but there's also a big fad component to it, where uh, a lot of people very senior in the industry, they keep saying, I want to have data science implemented in some fashion. And just because they want to have data science, just because they want to sound more complex, they keep proposing different solutions which may not actually be required. You may have a very simple solution which can work, or you may already have a solution which is working and they just want to implement something data science, right? So I have seen this with my own eyes, people doing this. Again, those are things that will at the end of the day not be deployed. So you should think about how much time you're going to give to them and how are you going to convince them that yeah, if the business wants data science, let's look at opportunities other than this problem, which are actually data science problems, and this problem maybe can be solved far more easily by other methods, or are currently already being solved by other methods, and implementing data science is not going to give you any added advantage. So that's a hard discussion to have sometimes.
Got it. So in your experience at Tesco Bangalore, you optimized store operations to ensure products are always available to the customers. Can you provide insights of how data science was applied in to achieve this goal? And I think a lot of operations research is also involved in the same.
Yeah, so I'm working with supply chain for almost half of my career, right? Uh, so initially I worked for one of the top 10 Fortune 500 companies, again, which is a supply chain client, and then I worked with Tesco, as you mentioned, and then other clients in the supply chain space, which are primarily a different, let's say, manufacturing client or something else, but I was working in the supply chain side of them. So I've looked at both ends. I have looked at from a, let's say, Walmart end or a Tesco end, something like a giant, big retailer kind of part, and also from the other side, which is a manufacturer side, how their supply chain looks like and how they respond to demand from different retailers. So it's actually way different in, although it's the same industry and it's the same supply chain, principles are the same, etc. It's very different how different people approach essentially what is the same problem, right? So at Tesco, I've actually not worked for a lot of time. I think I worked just for 11 months, and mostly related to store operations and how to optimize store operations. Effectively, what that means is where which items should be put, which items should be put together, which items should be put away from each other within a store, trying to make the store design and things like that. I think I already mentioned some of the challenges. How do you even deal with explaining this to store managers who may have different literacy with respect to data science, who may have different, again, it's not like one store manager, right? Multiple, whatever stores, that many store manager. So also some store managers obviously don't like change. I mean, no store manager likes change, and no customer at the end of the day likes change. So how do you convince them that doing some kind of change is positive and doing this specific change is actually positive? So that is a hard job to do, rather than actually building a model, which is, once you figure out what constraints are there and what data is there, that's not really the hard part. The hard part is selling this to the business owners and finally to the consumers, that yeah, the product that you were buying from here yesterday is no more here, it's somewhere else in the store. And the range that you were looking at, that is, let's say you were buying milk of some 250 ml, suddenly it's not there anymore, you only have 500 ml milk. And then you get complaints that, okay, again, which the store managers should face, that saying that this is a specific product I'm not able to find, maybe because we told them to remove that product from their range or something, or telling them that, okay, I can't find this product, right? Which essentially moved from one place of the store to another place of the store. So these are again challenges that the store manager will have to face because of decisions that we took. And that is why it's more important that we convince them that this change needs to be done. So you have your own challenges there. The data there is actually way more, let's say, very good data, right? At any retail store, at giant retail stores, you have data across multiple stores. You can actually do proper A/B testing. You can pick a store and then test it, and then take a similar store and then compare it. So you have a lot of these things ready for you. It's just convincing people and figuring out what challenges will come so that actually these things will not get deployed. That is, I would say, a bigger problem to solve.
Got it, Harsha. So, we will talk about two more work of yours. One, I saw in your LinkedIn profile that you work for human with AI machine learning tool. Absolutely fascinating. So,
Yeah,
could you take us through how this tool functions and the way it assists subject matter experts in identifying, performance and, failure in
sure.
aircraft engines?
So there is a paper called as Scarecrow. Again, you can find it on my LinkedIn profile. I think it's Scarecrow Intelligent Annotation for Aircraft Engines, something of that sort, which is published in ACM, where we discussed this, right? So this is something that we implemented, where essentially, okay, one of the premium that we have in the manufacturing industry, especially aircraft manufacturing and aircraft services industry, is that we don't have a lot of qualified engineers who can uh, monitor systems, right? And you need continuous monitoring when you're flying an aircraft engine or when you're
Right.
handling an aircraft engine. So a lot of these things need to be automated. A lot of these things need to be, um, uh, I mean, you need a lot of assistance to these subject matter experts. And what we have built essentially is a tool that just observes what these people are doing. So the subject matter experts either have some dashboards, Tableau dashboards, or some other dashboards, or a website, maybe a Flask-based website or something, where they keep looking at this data and then they keep taking decisions based on this data, whether the engine is going to fail, whether some challenge is going to be there within the engine, etc. This is over a period of time. So this is not like a 15-minute thing or something. This is over a period of 6 months, 1 year. They keep observing data and then they do this. What this tool does is it observes what the data, what those subject matter experts are doing. It observes what data that they're looking at. It observes what decision that they've taken, and it builds a model at the back end, taking that data and this decision into a classification kind of model. What that can help is in the future, whenever a similar case occurs, it can auto detect it. So a lot of work that is done by SMEs where is just detecting non-failure cases or detecting extremely failure cases, which this model can automatically do. And it can reduce the amount of data that is observed by any specific subject matter expert by almost 90%. So only edge cases and cases that are way more difficult, uh, those are the only cases that a subject matter expert would be looking at. That is also more useful for us because as subject matter expert is looking at more edge cases, our model will also be learning on more edge cases. So in that way, it can improve our model as well as improve the predictability for the subject matter expert. One of the challenges in this project is when to stop, right? You shouldn't essentially overtrain the model. So that's a major challenge, but at least from a conceptual point of view, I think you understood what that project is about.
Got it. So I think it's gonna be of great help for the aircraft manufacturing industry. Where
Yeah,
they need to figure out that when the engines are going out of order or all any such parts are required or maintaining the inventory and so on. Yeah, great man. So Harsha, you have also mentioned being involved in the optimization of rewards and recognition programs for a reputed insurance company. And how did you leverage predictive and prescriptive analytics, to optimize these programs per se? And what kind of impact did these organizations have?
So this was a part of my project at IIM Bangalore. It was a capstone project that I did along with one of the India's larger life insurance companies, right? So we had data of, so what happens in life insurance companies is they don't have employees who then sells these products. They have agents, right? So if a company wants to, let's say, sell product A more than product B, uh, if you are working for a company, they'll just tell you, see, sell A more than B. But if you're working for something like a life insurance company where you're not actually an employee and the company cannot directly tell you to do things, the way it does this is using rewards and recognition, right? Uh, or a company can say, okay, this is March, this is the peak time, you should sell more directly to their customers or to their sales agents. Versus if you're a agent, if you're working for something like life insurance companies, they can't do that directly. So the way they handle these things is using a rewards and recognition program. Again, you should then figure out what kind of R&Rs you should provide. That is, there'll be again different kinds of agents within the organization. Some agents might be part-time, some agents might be working on other products also at the side. Some agents might just be working on your products full time. Different structures, and for each of them you should then figure out what kind of things will work. Some agents might be extremely large sellers, some agents might be small sellers, so you shouldn't ignore small sellers for the large sellers. At the same time, you shouldn't ignore large sellers for small sellers. So contest that says if you get 1 crore of sales, we'll give you some award, might not work for small sellers who are not going to go that far. And a contest that says if you get 20,000, we'll give you an award, might not actually work for 1 crore sellers who can potentially get 1 crore. So the first thing that we needed to do was, what is the potential that, okay, first thing is we needed to bucket different agents into different buckets based on different metrics, not just the amount sold, but also region. Again, a person in Mumbai would sell more, let's say, than compared to a person in somewhere in Hyderabad or some other place in rural India. So you should figure out, okay, someone in Mumbai with higher sales is one bucket, and someone in rural India with lower sales is another bucket. So you should first do some kind of clustering kind of thing where you cluster individuals into different buckets, agents, and then figure out what should be the limits for these agents. Like, what are achievable limits for these agents if you put enough rewards and recognitions programs, right, within each cluster. And once you figure that out and once you build that, then you have to see whether what is more reward. How do you get? I mean, you can give too much rewards. You'll get more sales, but it may essentially be less profitable for you, right? So you need to optimize that. You need to optimize essentially revenue and profits with respect to whatever you're spending. That is the R&R contests. So these are different levers that you should see, that is spends versus returns. And also you should see that these spends are, there's already a predictive component to this. You're already predicting that people will, if you give this R&R contest, people will spend so much, or you'll get additional revenue of so much. There's already a predictive component to this. On top of that, you have to then optimize. You have to optimize a prediction. So this is like, I think in statistics, taking averages of averages doesn't, doing a prediction on top of another prediction is actually more challenging. So, yeah, those are what you should be careful about, that it's already a prediction on which you're doing things. And yeah, that's essentially, I think, what the project is. I think I try to explain it from.
Just give me a minute. Just give me a moment. Harsha, so if we take a step back and look at, deployment of machine learning models or any data science solution per se, uh, what are the factors, which contribute to the success of the, data science models and, any machine learning model, if we look at a little, from a general point of view?
Uh, I would say business objectives, right? So even before starting a project, you should figure out how do you quantify success in this project. It's hard in a lot of projects. It's not just metrics, it's not just numbers in terms of revenue or in terms of profits in a lot of these projects that we build. For example, the one that I spoke about for uh, subject matter experts, making their life easier. How do you quantify that, right? How much value do you put to that system? And what kind of inaccuracies are you ready to agree with for building this system? So, for example, in this case, if let's say 1 out of 10 cases are missed by the data science model and they're not shown to the subject matter expert, and decision is automatically taken from the backend, is that an acceptable failure rate? What is acceptable failure rate? These are questions that you should understand before you start a model, and based on these constraints and again explainability and space kind of models that you can build, and IT challenges and all of these things come into whether a model will be deployed or not, and whether it will be successfully deployed or not, and whether it will require major rework and other challenges. So these are all things that you should think before you actually implement, and I would say largely depends on how you understand the business requirements and how much the business itself has a clarity on the problem. So generally, that's also a challenge, that business has some directional inputs, but after you discuss with it, then they'll have a much more clarity on, okay, this is what the problem is, and you discuss more and then you get a little more understanding and so on. So yeah, that is also another thing uh, in terms of how do you deploy a model. Also, it should be a little more agile, I would say, because you build something, you think, okay, this might be useful, and then you actually implement it and you find out that it's not useful. Or you might have thought in the future that I would implement these things, and based on that, you build something now. And once you deploy it or have some test cases or some A/B testing done across different stores or whatever, you figure out that that's not really the case. So you should be agile enough to change your plans and base your strategies based on what the business and the customer wants. So yeah, a lot of these things are actually they're all dependent on each other at the end of the day, and you should take a lot of these into consideration uh, before your actual model and your actual project is successful as such.
Got it. So two big key takeaways from here, like, identify how would you quantify the success of that model, and
Yeah.
then the second one comes, you know, if let's say the model is not successful, then how, quickly will you be able to pivot and, build a better model that will be more useful per se. And yeah, so Harsha, we will switch gears a bit here. So let's say what your typical day as a data science consultant looks like.
That depends on which state I am in the project. So if I'm in the initial stages, it's a lot. See, I'm a consultant, right? So I work for a significant, for a significant but not short, not a long time on a project. And largely these days, it's almost end-to-end kind of project. It's not like a small part of a major project. Even if it's like a small part of a major project, a lot of these discussions still happen. So initial phases, it's largely discussing with the business, understanding what they want, discussing with different teams, understanding what currently exists, understanding why that is not sufficient, why did they come to us, and doing a lot of research on that domain. The advantage that I have working as a consultant is that I look at multiple domains across my across an year, right? Let's say. Um, so I'm not stuck with one domain and one type of problems. The same problem can be in a different domain and can be completely different.
Mm-hmm.
So yeah, so research on that domain, research on what the business is doing, etc. So a lot of time goes in that, and then it's actually talking with subject matter experts, figuring out what the features are, etc. And then then there'll be days when I'll be doing EDA for the whole day. And a lot of this is directional EDA, where we again speak with subject matter experts and clients and people like this who tell us that okay, this is what should happen. Just check if this is what is happening, and then we do EDA for that, and then we see whether there are any explainable reasons for that thing happening and things like this. And then finally we build a model, and then deployment is another thing that will take again weeks to sometimes even months, depending on the IT infrastructure, IT challenges. It's more challenging that way because you don't even know what IT you require
Mm-hmm.
and what IT is allowed and what IT is not allowed, and all of these things, which will again take some time. So deployment itself takes a couple of weeks. Uh, so it depends on how my day is, depends on what period I am in the project, essentially.
Got it, Harsha. So, you know, let's assume right now that you are a, freelancing data scientist, and what's something, that should be there in an email from a client for a new project, that makes you open that email twice.
It makes me open that email twice. Something that I have not worked on and is still within the realm of industries that I have, let's say supply chain or manufacturing, or these are the industries that I have worked significantly with, and something that I've not worked in those spaces. That would be interesting because it would be looking at the same problem in a new way, right?
Mm-hmm.
It's like uh, having a new baby, kind of thing. So it's an industry that I know, it's an industry that I worked with before, but it's a problem that I've not known and I don't have an immediate solution for it. So that is a problem which that is a place where I have more knowledge on the business and less biasness in terms of building a model. Because again, after a while, you feel that everything is a nail and you have a hammer, right? That is the data science world. Everything looks like it's a classification, regression, clustering, or something.
Mm-hmm.
Some of the problems that you currently work or you previously worked with. Everything looks like a nail, and something that doesn't look like a nail, but it's another thing that I've worked with that makes me look twice and
Got it.
be like, okay, what is happening here?
Got it. So, Harsha, let's, last but not the least, let's say data science and analytics is not in the picture for the timing. Okay. What would have been your next best passion?
Oh, mechanical engineering.
Okay.
So even now, I'm working on largely mechanical related solutions. I'm working with Achyuthuni, which is a mechanical engineering, heavily mechanical engineering based system, where a lot of physics and a lot of sensors that I work with have uh, some basis on mechanical engineering concepts. You need to know at least the basics of Brayton cycle, other things. Before that, I worked with supply chain, which is a part of again mechanical engineering. And even now I'm working with, let's say, manufacturing clients and pharma clients, again in the pharma manufacturing side, which is again largely mechanical engineering. So I see a couple of mechanical engineers who are data scientists, and again from an Indian point of view, let me say this: mechanical engineers who are data scientists have their niches which someone from a computer science background will not be able to
Absolutely.
do that effectively,
Mm-hmm.
because you need to have that understanding of pressure versus temp. I mean, see, these things you may not know while going in. So how an aircraft engine works is not something that I knew, that I learned when I was in my bachelor's. But these are things that you can learn in the when you're working, versus a computer scientist who does not have that background also will not be able to do that. So computers is something that you can learn, but learning mechanical engineering concepts from scratch is far more difficult. Not impossible, but let's say far more difficult. So that's a niche which exists within the industry where, yeah, if data science did not exist, I would have been a mechanical engineer, proper
Got
mechanical
it.
engineer. Even now, I'm a mix of, I'm in the same industry, but working on data within that industry.
Got it. Got it. Got it. Got it, Harsha. So thanks for making the time again and coming here.
Okay, thanks a lot.